The first programmable controller were introduced to the industrial control in the early of 60s to replace the relay control panel. When new control requirements need to be implemented, it was not economical to modify the logic of these panels, which often result in the redesign and acquisition of new panels. So that's why the controller, the PLC, you can see that we save money because we can introduce features and new features and new functionalities without to rebuild and redesign and the application. Here you can see the picture of a relay panel from the 80s, for example, or 70s, and how clean is using an old model of our PLC. This is an AFRO-ALTUS PLC, older, maybe 85, for example, 80s years, of course. And you will see that it's much more clean, your cabinet, comparing to this. So we do all logics inside here and substitute every interlock logics that we have here. And of course, can you imagine if I need to introduce a new logic here? It's too difficult to, and you don't have space, and you have a lot of wire here that you need. So it's much more simple to do this inside the PLC with the software changing. Here another example. So here we have our old, not that old at the last one picture, but an old series that we have, the Ponto series, comparing to this kind of application. So of course, this is much more clean than this. This is some pictures of some revamps, some modernization that we made in last 35 years. So why use a PLC? Easiness of programming and maintenance, high reliability, smaller dimensions, as you can see in the last pictures, compared to the relay panels, cost reduction, of course, communication capability for centralized processing, and of course, competitive price. The first programmable controllers were introduced to industrial control in the early of 60s to replace exactly this panel, these relay control panels. Okay, but how does it works inside? Mainly, we have this. We energize a PLC, we read the inputs, runs the application code, the interlocks, and write and update the outputs. So when the PLC is turned on, the microcontroller performs several tests before starting to run the application program. The memory's processor main electronic circuits are tested and retained data restored. Step 1, the PLC reads the values of the inputs through the I/O modules and store this data in the area of our RAM memory, the memory image of the inputs. Second step, it runs applications accessing the data image memory of the inputs. The result of these command lines of the application programs are stored in the RAM memory, the image memory from the outputs, and then updates the outputs. So it updates the outputs of the PLC, the results of mathematical operations, timers, counters, and so on, copying the data from the image memory of the outputs, and then go again and doing this cycle for life. Here, basically a picture showing this. We have, of course, COM ports here or Ethernet ports that connect in the programming that we will receive the interlocks and the code application. And of course, not the serial port or Ethernet port and can connect to the HMI. We have the memories here, the EEPROM here, flash, the I/O storage here, real-time clock, watchdog, and of course, everything connected to the CPU that receive from the input modules, digital or analog input, processing the logic, and write the memory to the output modules. Well, let's talk a little bit about the IC 61131 part 3, and of course the code Cs that we are using, and you will see in the next sessions this word a little bit more, because it's the main software that we use in our PLC. Well, what is the IC 61131, and why I'm bring this to this presentation and to this course? Well, this IC is an international organization that made up representatives from all around the world. The IC 61131 is the first real effort to standardize programming language for industrial automation, because in the beginning, of course, every brand produced his own language. So to try to standardize this IEC was created. The main aspects is programming language, portability, this is very important, and software reuse to give to the customer a little bit more easy way to reuse these. The IEC 61131 has 8 parts, and the third part referring to exactly to the programming language. So when you see some control, some PLC that it's following this standard, you can for sure you will find exactly this programming language that is listed here: structured test, sequential functional chart, functional block diagram, ladder diagram, instruction list, continuous function chart, and here is the presentation of the graphic of this one: SFC, FPD, ladder, IL, and CFC here, and structural test here. So you can we can support these 6 languages, and we can choose for one thing one language, and for the other thing, for example, to do some interlocks, ladder, it's better than, for example, structural test, but to doing some mathematical calculations, it's better to use the ST than the ladder, for example. Here, the main features, engineering features in the 61131, that part 3 is that if a controller, if a PLC, it's follow this standard, you will see these 2: the online debugging, online chains, offline simulations, symbolic variables inside, easy hardware configuration, system diagnostics, global variable list, and so on. Of course, the backup features, source code memory inside the PLC, it can be stored too. Wow. But what is Code Sys and 61131 has in common? Actually, this is the point. The Code Sys 3S Smart Software Solutions has his headquarters in Kempten, Germany. It was founded by in 94 by Dieter Haas. More than 100 software engineers there. The company is certified ISO 9001, and products that Code Sys has: Code Sys engineering, runtime, visualization, field bus, motion, CNC, and safety. Millions of Code Sys compatible single device, over 1,000 different device types from more than 400 manufacturers, and tens of thousands of Code Sys end users across the globe prove that Code Sys is the leading manufacturer IC 61131 programming. So what I want to say, describing and marking in yellow this, if a controller is used by Code Sys, we can change the codes and change and replace, and the guy that is training at the Code Sys can programming any hardware that is use the Code Sys programming. So it's very important for the customers to use something that is very open, and we can reuse, for example, the brand A to the brand B, C, or bring back to us or leave us, and the code will be the value that the customer has. Just talk a little bit about how the code sys works. We have a task execution control here, an execution control element in the process of IEC program. A task is defined by a priority, so we can have more than one task and with different priorities. We can choose this task running cyclic, event, freewheeling, or by status. That will trigger the start of the execution. POU, Program Organization Unity. So we can write here, for example, POU ladder, functional block diagram, and sequential functional chart running at this task. And here we have a second task inside the same. You can imagine that this is a POC. We can have a second task here running as an event, receiving from an outside trigger to running this other program organization unity that is the same that we have in the older concept, the subroutines here. And of course, a database here that we call global variable list. It's here that we can be accessed from every one of these subroutines. So basically we have here in the CPU, the code sys running in our PLC. Of course, I'm empowered code sys because you will see a little bit. It's not the pure code sys, but you will see in the next sessions that we take the code sys and we enrich the code sys with, of course, our hardware, our libraries, our diagnostics, and some functionalities that you will see in the next sessions. But mainly we have the same picture that we had before here, exactly running the code sys here and doing the same thing that we talked a little bit earlier. Okay, let's talk a little bit about architectures. Here, this picture can show you the architecture that we can have here, for example, from the compact controllers connected to the same ring, to a medium size for machines and mid-size process. So for machines and small process, we can use the compact that has embedded features to connect for a cloud or SQL. And here for a medium size, mid-size process, connected to inverters using HMIs. Here again, for large machines and medium-sized process, another way to use. Here with a distributed I/O, so we can use modular systems here next to systems to connect to a modular remote I/O and to connect to another compact here. Here we have a sample for safety automation with seal-free. And our next series here with redundance for high availability. So here you can see that we have two main processors running at redundance and the network here, 2 bus redundance at with 2 heads here in the I/O and with hard connection. So it's just to show you some samples, and here our RTU for power automation systems and to use in the power generation, transmission, and distribution with the main protocols of the electrical segments. Mainly we can talk about IEC 61850 and DNP3 and IEC 104 here. And of course here, We have the blue plant, the SCADA, double ring here for redundant and fault tolerant systems. The form factors. So basically we have two form factors here, the compact one, PLC, and the modular one. So as the name suggests us, the compact one, you have the CPU and embedded I/O connected. And the modular one, we have CPU, power supply, I/O modules connected, and bus function to expand. About the PLC types for mounting and fixing, you can see here mounted DIN rail. So this our compact the express, it's connected in the it's mounted in the DIN rail. And here an sample using the modular one connected, the chassis, the backplane connected and screw directly on the panel. The main components of an automation panel consist basically of these: circuit breakers to supply from the AC voltage here and to feed and supply the power with AC. This power supply just convert the AC voltage in DC 24. Load contactors here, device, for example, motors control, that the command is sending from the PLC, of course, and the power is going to the motor. Here in some other device that can be used, interface relay, just to support the load, because of course this compact have limited power current actually to support. So we use this kind of relays here to support. I think, for example, if you have some valve that consumes 5 amps or maybe more, you need to use these interface relays. Here, example with IED, intelligent electronic device. For example, here a frequency inverter, and all of these connected to a PLC. Here, I will present to you our, let me just here, our 3 series, basically the next 2 modular, the express, and the master 2 programming. So let's start with the modular one here. So this is our modular one. You can see here power supply, CPU, and the I/O modules here, and the expansion bus here. Well, wide variety of CPUs and I/O modules. I will show you redundance of CPUs, power supplies and communication modules, power supply monitoring, control, and field networks. Well, this is some key points. We aggregate the DCS typical elements, integration with the most traditional SCADA systems, and use it for control system in small, medium, and high-end application. Market, we talk a little bit about this: oil and gas, machinery, agro-industry, power, water and wastewater treatment, food and beverage, transportation, building automation, and distributed process. Here is some distribution. This graphic show you how can we separate and segregate our CPUs models. The mainly is here the compact one that we will talk a little bit more in a few moments, and 3003 with modular with I/O embedded, and this one, these 3003, 4, and 5 with power supply embedded, and this is our more stronger with more capability memory, so we can support the redundant system, support networks, and without power supply embedded. So totally modular systems here. Some points about this: modular architecture, innovative design features, and super finishing using materials such as aluminum and plastics and LCDs. You can see here. We received this seal here, product, and this awards, product design awards in 2012. ROS directive, so restriction of certain hazardous substance. Here, it is an European directive which prohibits that certain hazardous substances are used in manufacturing process. We have the conformal coating here, so we are ready to protection against hazardous environment and for electronic components, extreme temperatures, sea air, humidity, among others. This is our certification. So we have CL, UL, DNVGL, and ASC. Diagnostics, all diagnostics available using the web page embedded. So you don't need to have the master tool installed in your computer to check how is the system and the diagnostics of the systems. You can do firmware update via web, remote access, and of course we have password protection. Built-in compact graphical LCD, so we can see here some status and diagnostics. The one-touch diag, so we can talk to the CPU using this push button here that we have here. Remote access, supervision and monitoring, telemetry. We have an HTTP server. We have a web server. We called in this CPU, of course, an X3005. We have the web visu. Here, high-speed I/O modules. This is our economic modules, I/O modules, cost-effective for either machine or distributed systems. And okay. Let's talk a little bit about the Next2Express here. Next2Express, it's our small and smart, and we trying to say that this is much more than a PLC, because you will see this is our gateway, our gateway for Industry 4.0. And why I'm saying this, because this part here that we call heart of the Express, because of course we have the I/O here, input and output and analog and digital, but you will see that we have a very powerful, very powerful capability of communication. This is a little bit about the Next2Jet, and let's talk about the Next2Express. Finally, I'll just present the final gap into this portfolio. So we talked before about the Next2 series and the Next2Jet, and now we are talking about the compact controller with embedded. This product is based on our knowledge and experience, but delivered in a compact form factor in order to fit standalone and low I/O application. We proudly present you our new technology platform, Next2Express. The market that we are seeing that is very, very important, and of course we have much more, but mainly in the OEM machine, food and beverage, textile, building, water and wastewater treatment, and transportation. Here is the Next2Express. Mainly applications to 0 to 43 I/O points, and using the Blue Plant Light or SCADA systems. So here we have some key points that I want to talk a little bit about. It's we call that this is Industry 4.0 ready because we have Ethernet, OPC UA, MQTT, the IEC 61131 is presented here. Super features and competitive pricing, it's very important. Very open because we have MQTT, OPC DA, OPC UA, Modbus TCP, Modbus RTU, and can open. That's why I call this the heart of Express, because we have all Ethernet protocols coming outside here, connecting here. The RS485 here to communicate to Modbus RTU. The can open, and other can as can low level. So smart engineering, easy to use software, online chains and simulations. This is exactly what the IEC 61131, as you know. Code is embedded, power enriched and powerful code is that we produce. And of course, it is scalable. The next family covers small to large solutions, and we can create an architecture using more than one of these to support other applications. So as we talk in the heart of Express here, RS485 can port here, can open embedded, and J1939 and low level available. USB port, so here, storage. We can use a USB stick here, or a 3G, 4G dongle, or a wireless dongle, so we can use the same protocols, for example, MQTT or OPC UA through the USB system, or even programming this using the 3G, 4G. And here in the Ethernet port, we have Modbus TCP, Ethernet IP, OPC UA, OPC DA, SQL client embedded for connection to Microsoft SQL, IEC 104 that bring to us some parts of the electrical information and very useful to the telemetry. Web server embedded, so we can use pages, and we can create pages embedded. We have the RT, is the code sys protocol, and MQTT ready to use. So when you buy, for example, the 340, all of these, it's available to use. And that's, in my opinion, a very, very great difference from our brand to the others, because we don't, all of these protocols is available. For example, in the 325, we have all of these, even just IEC 104 and web server is not present here, but the 340 have everything, and the 300 have everything, but not this and this. So, product highlights: GIM rail mounted, compact design, 24 VDC power supply input, high speed. This is very important. It is very, very fast. We have a 32-bit ARM processor, based processor. High density of I/O, up to 43 I/O points in a single product. Multiple purpose, analog inputs, voltage, current, and RTD. LEDs for inputs and outputs, states, indication, extractable terminal, real-time clock here, MS SQL client, as I said before, to support to write and to do some queries in our database. Again, Modbus TCP, OPC DA, MQTT, Ethernet IP scanner, programming and configuration through the Ethernet, Modbus RTU master and slave available, can open master, can low level, I/O expansion we can do and we can produce here. Can create some application with I/O expansion in can open. Data logger, programming and configuration, and smart device as modding 3G, 4G dongles and Wi-Fi dongles we can connect. Digital inputs, digital outputs, opto-isolated. So this is basically the specs of our products. Analog inputs, 12-bit resolution, so very high to a compact one. Analog inputs and outputs, both 12 bits. The analog inputs, mainly voltage, current, RTD, and linear potentiometer, for example, resistance. For analog outputs, 0 to 10, and current 0 to 20 milliamps and 4 to 20 milliamps. The same, basically the same feature and certification that we have in the next two here, ROS. Conformal coating. So again, for extreme temperatures, shear, air, against corrosion. Here we have a presentation about the small and medium application that we can produce, for example, the web page embedded. So using the 340, the Express Model 340, you can produce this web page inside the main controller. Just an overview about the product housing, the dimensions here, diagnostics, LED, power supply here, communication ports here, analog and digital outputs and inputs here. Some samples about applications, OEM machines, label, filling, washers, injection machines, package, grinders, and presses that we are using here. Building automation, lights, climate, supervision, conveyors, access control, water and wastewater treatment, remote control sites using the IC or the 3G or the 4G dongle functionalities, pumping stations, reservoir level controls, and that's it about your powerful compact. And let's talk a little bit fast here about our programming tool. So this is the master tool screen and easy. And in the next sessions, we will open and we will do a hands-on. I will show you how to open and how to configure something. So in the next sessions, we will do a hands-on how to configure this. But it's an overview about this in an easy to use software for all your products needs. We have the 6 program languages, of course, as we talk a little bit about 61131 following standard using the code sys, but it's not the pure code sys. So master tool, it's the software that we take the code sys, we enrich it with our libraries and give you to more friendly user interface and easy to use. Single control platform with modern programming environments, online programming, offline simulation. Of course, this is we follow these standards, so we have to do these. We have to have these. One very important point, from the compact one to the redundant system, we use the same tool. So if you produce some codes here and you need to reuse these codes here, you just copy to a redundance or a modular or a next-to-jet system. So it's very, if you know how to program these, you know how to program and create application these. Allow a fast and comprehensive way to configure the system, advanced edition, first integrated, standard communications, graphical bus, as you can see here. This is a screen from a project. Autocomplete features and integrated help, files for easy programming, object-oriented programming, simulation tool, prints out of user applications. We have the build of materials inside, so we can create an application here, and we have the build of materials available. Program organization unit is the subroutine, configurations, parameters, tags, and descriptions. Docking view, friendly user interface, allow to customize. Here, again, offline application simulation, online application debugging, as you can see here, monitoring of variables, symbolic variables, system diagnostics from the software, use of breakpoint if you need to check and test your application, communication with SCADA and HMI simulation using the OPCDA. Here the same slide that we saw, the 6 language that we follow, of course, because we are 61131 follower. And this is an overview from our products, and in the next sessions you will see we will work with this and mainly the Express that I have here in my hands, and I will show you. Okay, let's talk a little bit about the factor for choosing. Wait a second, please. Wait a little second. I'm receiving a message from my colleague Fernando Stouts. There is an asking from Mr. Hassan. There is asking for 10 minutes for question and answer Q&A. So okay, I'm available. You can do that.
Mauricio, yeah, this is Fernando talking. We can have the break in 10 minutes from now, so you can continue, and then in 10 minutes we're gonna have the break. Yeah.
Okay, perfect.
Let's. Everyone.
Okay, now I got it. Now I got it.
Ask questions then.
Okay, now I got it. Now I got it. So prepare your questions, please, and I will present this factor for choosing a PLC, and we can stop, and then we can move on. Okay. So basically, the factor for choosing a PLC, and then that's the point, when to use a compact PLC or a modular PLC. To answer this question, we need to know the answer of the following questions. So we always need to know, as a developer of system, or the I/O quantity, the I/O types, the communication protocols needed, and the I/O distribution, if we have one or more panels to put this. So we create some examples here. For example, this one. Example 1. The application needs 4 outputs in PWM. Pulse-wide module. It's a kind of modulator. It's a kind of output, very fast. 22 DOs, digital outputs, 28 digital inputs, 9 analog inputs, 3 analog outputs, and Modbus RTU and web server. So to fit this, the more economic and power solution that we can provide this, it's to Express 1340 that supports the web server. Expanding in can open the second one, the 315 that we have. So we have 5 analog outputs here, plus 4 analog inputs here. So 5 plus 5, 10. So we support these. 3 analog outputs. These 340 support 4. And 28 DI here. The Express support, each Express has 16 digital inputs and 16 digital outputs. So we have 32 digital outputs and digital inputs. And if we sum these 4 to 22, we have 26. So we fit with these 2 controllers using these as a remote I/O expansion, actually. Connect at the same panel or in other panel, it depends on the distribution, but we can use these. And the Modbus RTU here, master or server, or I'm sorry, master or slave, connected here. Another application needs here 64 DI, 32 DO, 8 analog inputs, 5 analog outputs, and Profibus DP as a field bus. So to support and to fit this application, I used 3005 CPU with power supply embedded, a master Profibus here to connect to other device, or maybe the inverters or soft starters or other device that can communicate in Profibus DP, and the NX modules here using the 1001. Here digital inputs 16, 32, 48, 64. And here NX 2001, 32 digital outputs, 16 plus 16. And here NX 6000, 8 analog inputs, just one module. And here NX 6100, two modules, because each 6100 support 4 analog outputs. So we have 8 analog outputs available here. Example 3, the application needs redundant system, fault tolerant only in the CPU, not in the connection of remote. Field bus, the supplier can suggest a total amount of 120 DIs, 80 DOs, 16 analog inputs, and 16 analog outputs. 120 digital inputs, 80 digital outputs, 16 analog inputs, and 16 analog outputs. The architecture that I create here, it's exactly our 3030 and X3030 connected in our redundance coprocessor here, and using Modbus TCP to connect it to 2 slaves here that will feed the CPU with the I/O that it's distributed here. So I share this for 2 and put 60 available here, 60 DI here, 60 DI here, 40 here and 40 here, 8 here and 8 here, and 8 here, 8 analog inputs here, and 8 analog inputs here. The last one example that I take here, it's a factor for choosing a PLC. The application needs 240 digital inputs, 160 digital outputs, 40 analog inputs, and 20 analog outputs. The customer wants, or the application needs, and we can use a bus expansion, SCADA license, the number of the tags. So for the hardware, I create this. I create this CPU here with this backplane, and here the module expansion, right? And I'm doing a loop here and support the whole I/O. And this example, just to calculate the required SCADA license, a multiplier factor, it's usually used to the number of points. This is because we can connect to tags that are only on the PLC, such timers, set points, alarm generated by logic, or hardware diagnostics. For this case, we will use the factor 8, which give us 7 virtual points that is just inside the CPU for each I/O point that I have connected from the field to my PLC. So doing this calculation, we have this, the sum of whole application tags and points, I/O points, for 460 I/O points, and multiplying by 8, we have a 3068, 680 SCADA tags. basically we need a license about 5,000 because the main SCADA systems it's support from the 1.5 thousand tags to 6,000 to 5,000 tags. I'm sorry. Okay, let's talk a little bit about questions and answers.
So maybe Mauricio, if you can tell them a little bit about the processor of Next Express, and then there's another question that Mr. Fernando Train already answered, but if you can tell them a little bit more about the RS-232 and RS-485 connections for Express.
The first one question, please, can you repeat?
No, it's just they have asked about if the question is, can we have both RS-232 and RS-485 versions of Modbus RTU? This is the first question. Mr. Fernando already explained it, but if you can tell them a little bit more about the connections.
Okay.
Yes, I think it is pretty well explained in the chat itself.
Okay.
However, I have few other questions. There are different kinds of protocols. For example, we have fire alarm protocols like Simplex 4100, and there are others from Honeywell. Is it possible for us to write our own drivers on your platform? Second, BACnet protocol in itself is one of the fastest growing protocol. Does it support BACnet MSTP considering its timing cycles? Thank you.
Okay, thanks for your question. The first question about writing his own protocol. Yeah, it's available. For example, for the serial port, it's available the free port libraries that you can, if you know how to use and we have if you know how to works the protocol and using our library and our help, you can see that you can create your own protocol. For example, a weight level that send us information about in ESC2, and of course ESC2 it's a form, it's not a protocol, but I can, if I know the markers, I can use these markers to receive these and understand and interpretation and collect this information. So yes, we have available these features and these libraries to use. And the second one, can you repeat? It's about BACnet and the BACnet. Can you repeat the protocols that you asked? It's a BACnet and
yes, that is BACnet, BACnet IP, and BACnet MSTP.
Okay, actually we don't. It's in our roadmap. Support this, and this is just if we can put this available, if we, when release this, it's just an update firmware. But now at this time, it's in our roadmap and under study if we will develop or not. So many information about these needs and this opportunity can support us to produce and then to put a little more asking about this and pressure in our research and development to provide this. But at this moment, we don't have this backnet. It's just in our roadmap.
Sounds good.
Any other question?
I would also like to ask a few things. There are some other protocols which have some stringent timing requirements. For example, the token must be used with within 15 milliseconds of reception. Breaking these rules generally disrupts the communications. I would like to know if your hardware is qualified for qualifies for being a platform and is suitable or pertinent for this kind of development.
Okay, if I understand well, we just asking about our hardware and the timestamp, the accuracy of our digital inputs and digital outputs. It's that, am I right?
I'm talking about analog inputs, analog outputs, digital inputs, digital outputs, everything. And I'm also considering the fact that there are timing cycles as well. For example, the token passing mechanism. How do you pass and how fast? What's the frequency of token passing when it comes to your hardware? While you might have implemented Modbus stack, you generally would not receive such limitations. For example, if I'm working on an application for monitoring energy consumption on a cluster of campuses, then say my protocol would use 280 threads, and on each of the thread there would be multiple sockets, right? And the total throughput would be 186,000 present value reads per second. It have you
And
does
this protocol that you are using, it's your own protocol or it's a standardized protocol?
it is a standardized one.
And what is the model? What is the
Uh,
protocol? Or
the there are I have approximately 146 such well-defined protocols in my mind, but I would focus I would like to keep it short. I would like to focus on the BACnet IP and BACnet MSTP only, because this is the fastest growing ones. It is the most it is very well documented by BTL Labs. So we have a very detailed security addendums, as well as we have a very well specified document in order to create our own stacks and stuff. So my question in general would arise from that, but it can also be extrapolated to other various protocols in the market.
I got it. I got it. Let me just show. Let's segregate your questions. Let's talk a little bit about the. Can you see my screen?
Yes.
Okay. So let's talk a little bit about for example, how fast we can read and write our inputs, our hardware. So just to give you a sample, I have here analog inputs here. The conversion time from our hardware, it's about 400 microseconds. For this, for this, I'm thinking that we are talking about a compact one. So I take this as the example. So the conversion time, it's about 400 microseconds, right? So it's very fast because as you know now, the hardware, it's a very fast and a very strong hardware that we use here. And we can run, for example, the main task here in this hardware in about 5 milliseconds. So to collect and to digitalization the information from the field to the hardware, we are very fast. So now talking about the protocol. So to send this information through our Ethernet port or serial, well, now we don't have the backnet, so we can talk about the protocols that we have here, and as they are totally standardized, we need to follow these standards. For example, our Modbus RTU or our Modbus TCP or our OPC way, we can set exactly what the protocol rules and the standard rules. It's given to us, and it's open to every brand to develop. So what I want to say is it's this: the protocols follow these. The protocols follow these. Sorry for that. The protocol follow these standards, and the fast we can send information and receive information is based on this. The backnet, as I said before, we don't have development. These are this driver. So it's a little bit difficult to say to you exactly how fast we can be with the backnet. So I don't know if I answer your question, but we can go a little bit deeper inside of this question. Exactly, take a look maybe in your application, and how can we fit using other protocols, but backnet no. So I don't know if I'm clear.
Okay, so can you also? I just saw in the document that there is SNMP protocol mentioned. What version of SNMP do you have? Is it SNMP version 1, version 2, or version 3, or 2.c?
I got it. Now I got it. So you want to use the SNMP, this one?
Yes, yeah.
Okay, I need to check this. Wait a second.
Mauricio, while you check this information, maybe I try to add more information to Sandeep's question. As a general rule, the PLC is running the tasks averaging from 2 to 5 milliseconds. Okay, so the main task is going to, by standard, by default, is going to be set to 5 milliseconds, but can go down to 1.6 to 2 milliseconds. The protocols, usually they run, all these protocols, they are running on different tasks as well. So usually a Modbus task or a serial port task would run at as standard, maybe 20 milliseconds, something like that. Of course, you can set everything. If you have a client, you want to do your queries and everything, you can set these parameters on the software. But the idea is, depending on the load, the CPU load, you can actually go and how can I say, make it faster. Of course, it will depend on certain concurrent tasks, but usually the PLC will run between 5 to 10 milliseconds in average for all these kind of applications that Maurice was showing. So that's why we can run a lot of stuff on that. And to give you actually proper numbers, we would need to understand exactly what you're going to connect. But I'm sure that for these, 15 to 20 milliseconds, I would say time constraints, definitely we can do some settings, and you'll be able to run at least at this pace. So it's actually, imagine it's a 500 megahertz processor running just control and communication, so nothing else. So it gives you a lot of freedom to fine tune these tasks.
Sounds good.
Thanks, Mr. Train. Let me just check the type of the SNMP. Mm-hmm. Just a second. Here. SNMP Index controller, with support formats version 1, version 2C, and version 3, and support the MIB2, where required objects are described in RFC 1230. This is in our, I'm sorry?
That answers my question. Thank you so much. Thanks.
This is just to let you know, this is in our user manual express, page 107. Just to share this information to you. Okay, thanks again for your question. Another question?
I think I'm good. Even though I have a few questions regarding the MQTT. I'm not. Well, I know MQTT, but I am not very well versed with it. I'm working on it. Well, I mean, I don't know if it is within your scope and to explain it a bit. But if you can, it would be, I would be really happy if you can do that for me a bit.
Oh, thanks. Actually, we will talk in the next sessions about MQTT. Actually, I think the third sessions in 2 weeks, and I will show you exactly and connect my client here with a broker that we have, the test broker that we have installed, and actually the Mosquito brokers provider, or I can change. And but just to let you know, we will talk about a little more deeper about the MQTT, and I will show you how this functionality works exactly using our client here. Okay, so I can send you a link to connect, and you will see that how this stuff works. Okay.
All right, sure, please. Yeah, I would really appreciate that.
Okay, thanks for your interest in, and for sure we will talk about a little bit more about MQTT client and MQTT protocol, how it's working. Okay.
Will you also cover REST and JSON and these protocols, REST, JSON?
Today, in our library, it's not available using the JSON as an API or some or docking or payload. exchanging, but it's under study this to develop, and again, we can support this later, and when this functionality and I think it will be available in a few months, we can just update the firmware and this JSON functionality will be available in Express, but today it's not available. Okay.
Okay, thank you.
Okay. Just an information and just a spoiler. We have the cybersecurity TLS 1.0, 1.1, and 1.2 if a certificated authority can be stored at the Express to exchange and make this communication more safe. But we will talk a little bit, but we will talk more deeper in a few weeks. Okay.
Okay.
Okay, let's keep going here. I separated some application samples here to share with you. One application that we are provide using the Express here, monitoring of diesel generation using the J1939, and use the MQTT 3G 4G dongle to send information about how this engine diesel, this motor diesel, the engine diesel, is working, and how is the environment part of this, with the discharge of and emissions of the gases from this motor. This send information to the through using the MQTT just as a gateway. I receive this in CAN J1939 and send this MQTT using the MQTT 3G 4G dongle to the broker in the cloud. So using the J1939 MQTT features to send data from the ECU of a propulsion engine in the boats, environment project that aims to send data from the engine diesels of the vessel navigations in the road basin. This is a sample using a packing machine. We have a Express 325 here using and connected to the using the CAN open, the 3 inverters, and of course the I/O here, and sending information to an HMI using OPC-UA, for example, and can send information using the modem GPRS to the internet too. So very complete here. You can see the Express here, the inverters here. One important thing is main features, speed and accuracy, around 60 triggers per second, handle start and stop ramp close to 0. This is another example using the Express irrigation systems, Express 315 and 3 inverters, communication in CAN open, MQTT for the cloud to start and stop via mobile phone, Node-RED integration for dashboard, so the customer can see in the internet here the information using the Node-RED software. Weather forecasting, this is very interesting, and how can we use a way that we can use the Express. Weather forecasting, assisting decisions making for more or less water injection. PID control for pressure in the water segment, and the result is longer pipe life with fast pressure control. Of course, I'm using the PID. Reduce water consumption approximately 35%, because if I have the weather forecast here, I can decide if I need to pump to collect water from the river or the water treatment company, or if I want to wait the rain, because I know the forecast here, to fill my reservoirs. And here planning to water the plants up to 3 days in advance if necessary. If I have the forecast that will be sun, so I need to give more water to the plants here. So it's a very smart way to use, and how the automation can support and help us to in this kind of application, this agriculture business. Talking a little bit about the agro-industry here, we have a success story about the Bianchini. More than 8,000 I/O points here to control the whole plant. It's a soybean extract oil here. This is another food and beverage success story. Control and supervision of the units following process render, treatment, bottling, and loading the oil and margarine. Application with more than 4,000 I/O points. This is an sample for mining, iron or extraction plant automation. 700 I/O points in this mine. This is sanitation, it's water treatment and wastewater treatment. More than 50 units automated with the Nexto PLCs. And the Express as using as a pump station connection and to telemetry and to local control connected to a center. Textile. More than 200 controllers and 25,000 points, I/O points. And that's it. So now I'm open to another Q&A, and maybe you can talk about other subjects that for these first sessions we didn't present. So let me reopen here. Stop share here. Maybe Mr. Fernando try and then Mr. Fernando Stout want to talk a little bit more. Maybe I forgot something.
I think, Mauricio, maybe you can go back to the portfolio slide just to show them more or less how these PLCs compare to other brands, because they've been maybe used to a Siemens or Rockwell or some other brand. So just to give them a hint of, okay, these CPUs or this family more or less has equivalent features versus this and this family on this brand and that brand. So we can have this kind of cross reference between the Altus portfolio and others.
Okay. Here. Okay. Let me return here to here. Well, basically, the Nexto Express, it is a compact one. So the main competitors of the Nexto Express is, for example, the S7 1200 from Siemens, and the compact logics from the micro logics from Allen Bradley and Rockwell Systems. And here, the next to modular systems, this one, we can compare for applications from the S7 1500 or 1500 Siemens, and the compact logics. And at the same series here, let me just open this, and here, for example, this with embedded power supply, I think we can do the competition with the compact logics and some models of 1500 from Siemens, S7-1500. And this one here, we can compare with the S7-400 or 300 because we have redundancy here and then 2 Ethernet ports here and EtherCAT and support of more, the most part of our protocols that we have here. And of course, the control logics from Rockwell. And I don't know what is the main CPU brand that you are the guys here, the people here in the training that is used to use in his plants.
Yeah, I think it's important just to say that by choosing the CPU range and the I/O type, you can cover from premium applications with redundancy, field bus and hot swapping with conformal coding and everything like this, or safety and things like this. So you can go from a really premium solution that you're going to find on, the biggest and of course most expensive PLCs from the competition, and you can scale down your requirements, still using the same programming software. Everything you see here in this slide is actually programmed by the same software tool. So you don't need to go into training, or you don't need to have a different kind of software installed in a PC if you want to cover the very basic and simple Express, or a few IOs, or if you want to go really big, large, and do a complete process application with thousands of IOs. So that's the thing. And then when you scale down, you can see this different, of course, variety of CPUs. All the features and differences are based on tables on the data sheets. And then you can scale down, and you can use, of course, IOs that are not hot swappable, which of course saves a lot of cost for system integrators or end customers. And if you want to go for less density of IOs, or a more compact solution where you have less features but more economical PLCs, you go down to these NX 3005, 4, 3, and of course the Express is today our, I would say, entry-level solution. So everything is controlled, programmed, everything that they share the same thing. So if you are dealing with Ethernet IP, like a protocol on the NX 3030, is going to act the same. The drivers are the same from the Express, for example, or within the range. Same thing for the future, based on what Mauricio was saying about BACnet IP. So our next protocol in the roadmap. And once it's going to be available, it's going to be available. If we go for the IP, for example, that runs on an Ethernet port, you can then have it available within the range. So that's the goal here, is to, same thing with MQTT and those things. Every time we launch or release something like this, since you are using the same platform, you can use freely these protocols on the existing CPU versions. And of course, based on the IOs, you can then mix and match, the requirements, also offering good specs and trying to be very competitive once we are, of course, dealing with these large brands. So yeah, so I think this was an important message for you guys for this first session about the ALTUS. Thanks.
Thanks, Mr. Fernando.
Okay, so maybe Mr. Hassan, if you would like to ask any further questions, or you would like to say something. I think Mauricio has already finished his part of the presentation.
Okay, I think we don't have any more questions, do we?
Okay, then. So I think we can finish this session. We'd like to thank you very much for watching Mauricio's presentation. And We will send you all the information you have seen today by email later on. Mr. Hassan will forward that to you. And then we will be back next week for the second session then.
Okay, thank you very much.
Thank you guys. Thanks for your time. And again, it was a pleasure to join this session for you. And please, if you have some questions that maybe can appear today or tomorrow, please share with us.